So welcome back, everyone. Today we are going to discuss a little bit more detail, as I said, about object-oriented and how we can create a class with more detail. I'm gonna go add a little bit more about smart pointer, about overloading, about constructor and destructor. So the structure of class, I've discussed this with you before, and you have that understanding. Now we are going to add a little bit more detail. So stay with me. Most of the class, as I said, some kids that they just joined us. Most of the class, I'm gonna spend the time on Visual Studio, and of course, just program for you and implement all of these details that I just shared with you. So let me start with a little bit of theory. And right after that, we can continue with a little bit of practice on Visual Studio. So everybody, before I start, please make sure that you have your Visual Studio open. Just put it on the side, and then we are gonna come back. Everything I talk about it, I'm gonna program it shortly. So hopefully you guys can remember, how do we define a class from scratch? Anytime you are going to create a class on C++, here on Visual Studio, I'm using this platform, you need to use the term class. This is a quick review from the previous lecture for those who might not have a fresh mind about it. So you have to use class, give your object a name, that's optional. Any name could be your choice. And then right after that, what you need is your private and public members to be done right inside the class. Make sure class supposed to be closed with semicolon. That's mandatory. Otherwise, you're gonna get error. It's not like other functions. You finish up, and then at the end of the curly bracket, you do not need for function. You do not need to add semicolon. But for class, you need it. For a structure also, you need it. So I'm gonna look at another requirement in order to have a better platform for programming, like constructor. Constructor, remember I said we can have constructor with some parameters, or we can have a blank constructor with no parameter. What's the difference? If we have a constructor that has parameters, then we can say this is a non-default constructor. Simply means we can change those parameters. For example, right in here, I'm having width, I'm having length. This width and this length act like variable, right? Therefore, I can assign any size to the length and the width in this example. So that's why in here I say this is a non-default constructor. There is no certain number, there is no certain size, which is defined to be used for this one, right? So this is a general structure. If I'm looking at the prototype for a constructor, of course, I have to use, usually kids, remember, constructor could be the same name as your class. For example, in here, my class name, I'm going to maximize. In here, my class name was rectangle. Therefore, when I'm creating a constructor, my constructor name is rectangle. But in the case of the other example on my Visual Studio, my class name is box. Therefore, when I create constructor, I have it right in here. Again, I'm going to maximize. Look at here, for example, this is one of my constructor, just box. So constructor name is the same name as your class. That's also super important to remember it. Again, as I said, constructor could be default, like the one in here. Box doesn't have anything inside the parentheses. And of course, if I'm giving it some detail, if you pay attention, you can see all of them are set to a certain number. In this case, I set them to 1. It could be any other number, not only 1. It could be 0, it could be 1, it could be any number, 2, 3, whatever. But if they are set to a number, if they are set to a value inside the public, under the class, That's what we call it. This is a default constructor. Means this constructor or this object couldn't be any other different size. It must be only this size. In this example, width and height and length are 1. But if I do not have, like, for example, certain size, I'm having only the data type, of course, I can assign any other numbers while I am working on it inside the main. For example, that one, this is my default box, which is that default constructor. And then in here, I go back and I show you. Second one is a cube. Cube means, for the box, means length, width, and height are equal. We already had this example. I first initiated this box example using the structure. Therefore, again, I ask everyone to please and kindly go open the box example, and we are going to work on it and convert it to class. It was initially a structure. Now, today, we are going to convert it to class, and we will add more step to it, okay? So, now, if this one is variable, then I do have option right inside the main in order to give it any number. That's why we say this is non-default. And you may ask me, can I have C and C out instead of giving it maybe a number inside the main? Of course. That's another method based on the application. You can either get the user to give it some size after the compilation process through the console, or you can directly give it a size inside the main. Both of them are correct, but still both of them are considered non-default constructors. So far, so good. So constructor generally is a type of function, right? So you can just go ahead and give more detail to your variable or to your object. Right after that, I already explained this one. Another example in here could be rectangle. You can see it, rectangle has, for, again, in here I give it two examples, makes sometimes more sense. In here I ask my box to consider 1 for length, width, and height, and that's why this line 29 of my code is going to consider, this one is considered as default constructor. Another example inside my slide. In here I create a rectangle. I give it double width, double length, and if you pay attention, both of them set to 0. Still, this is also a default constructor. In this example, 0. In that example, 1. Doesn't matter what the number is. The only thing which is important is having a number, having a constant value, which is going to be the default value for that certain object, regardless of what the object is. Make sense so far? Still with me? So, now, another function member which I want to introduce to you today is going to be Destructor. Destructor, maybe you want to first understand what's the definition in human language about destructor. What is the application of destructor? Why do I need destructor, right? So destructor, we usually use it for the situation, as the name shows, that when we want to when we want the function to automatically destroy the object without us doing any extra manual programming in there. So whenever, like, the compiler is out of scope for any reason, it might be like, for example, out of range, out of scope, then if we do have a constructor, that constructor automatically is called and it will destroy the object and it will stop the processor. That's why it is really beneficial. Somehow it's coming to help you to save the processor from extra processing. Therefore, that's why we call it destroy. It will destroy the object which we do not want to continue creating it, or if it is damaged or whatever, it will destroy it. So that's the benefit of constructor inside the code. Another thing in here, I just said constructor can have default and non-default, but destructor is always default. We have nothing to explain for destructor. Destructor is always empty. It doesn't have any variable because it's supposed to destroy the object. I don't need any variable in there. So we do not have two conditions for destructor, but we do have two conditions for constructor. Please pay attention to not to confuse these two. So now, there are situations I'm having an object which is dynamically allocated, and I'm pretty sure everyone at this point knows that the keyword for dynamically allocated memory is new. We always use the keyword new. This is the keyword right in here, and this is the structure. So now in this structure, I'm having again a still rectangle. Rectangle is my class name also. And then this is the constructor. And then this one, the constructor is holding a pointer. How do I know this is a pointer? Because, yeah, asterisk. I'm having asterisk in here. This is a pointer. And then I'm having new in order to just practice dynamically allocated memory. So now, in this case, since I am using new and I'm using regular pointer, pay attention, because right after this, I'm gonna say what's the difference between this pointer and a smart pointer. This is a regular pointer. And then since I'm adding new, of course, I must add delete to release that allocated memory, right? This is a rule because we need to release the memory in case we wanted to use it for a different purpose. If we are using dynamically allocated memory, if we are using a more specifically pointer, regular pointer, we have to delete it manually. But always there is a risk that we may forget to add the delete as human, right? One thing is we may forget. One thing is that's an extra step. We have to do the cleaning job for the compiler. Somehow we need the janitor for the compiler. But what if we can just eliminate this part? Being a smart, and nowadays in modern C++, we have another feature which is called smart pointer. If we use a smart pointer instead of regular pointer, also we still need to dynamically allocate memory, but we are not doing it manually anymore. The smart pointer is doing it. We do not need a janitor to go clean up after the allocated memory, and a smart pointer can do it automatically. Therefore, today I'm introducing in here a smart pointer, and the most common one are unique PTR, shared PTR, weak PTR. There is difference between them. Unique PTR is just holding only, it's the owner or only maybe one object. If it is unique, if we are using unique PTR, it's the owner of one object. If we are using shared PTR, it's the owner of multiple objects as a pointer, right? And then weak PTR is addressing to the shared PTR without being the owner of them. Very similar to shared PTR, multiple object, but it's not really owner of them. It's just pointing to them. That's the difference between these three pointers. Now, in case you are going to use these pointers, these are not available under IO stream. We have to go ahead inside the main, right in here, get access to another header file called memory, right? In fact, I would say, if I'm going to summarize, what is a smart pointer? A smart pointer is the best way to manage your memory, and it's somehow automated. It's an automated managing system to manage your memory on behalf of you, right? And then you do not need to be worried about those delete and stuff. That's why even the header file is called memory. Make sense so far? So I have to go ahead, before everything, include memory in there, and then I can come, I have one example in here I show you, and we will practice it also shortly, and then I can simply use, for example, I'm going to look at in this example on my Visual Studio, my example is box, my object is box, therefore I'm having one object which is box. I do need only unique PTR. So I go ahead, I use unique PTR is a command which is like a keyword. You cannot adjust it. You cannot customize it. You cannot make it maybe lowercase, uppercase. It has to be exactly as it is. This is a keyword inside the memory header file. And then I can just go ahead, define the object for me is box in this example. This is a structure. Try to learn the structure. And then still look at here. Still I need the new, but the smart part of it is right after that. If you look at the rest of the code, I'm gonna finish up my main right in here. You see that I do not have delete anymore. I do not have delete anymore. Make sense? Because this unique PTR is doing it by itself. It has the ability to look at the memory, and right after it is using some for the box, automatically it will release it. You don't need to do it manually. Make sense? So this is the same structure as this one, is the same structure as what I just explained in here. And don't worry, anything right in here which is highlighted in blue, I'm gonna type them just one more time for you, and I'm gonna just explain everything to you once again in a few minutes. In addition to what I said about pointers, smart pointers, constructor, destructor, now one more thing that you need to learn is overloading a constructor. So far we learned constructor could have some arguments or no arguments, right? But in cases that generally even with no argument means even if I'm having a default constructor, still I can overload it without destroying it. Remember, constructor is not supposed to be destroyed. That's destructor, okay? Without destroying it, without again defining it, I can overload it. The same exact constructor, I can change the content of it. Maybe initially, like in here, initially I have a rectangle, which is a default constructor, no argument, empty, but still I want to hold that default constructor. Next time I'm gonna load it with some other information to become a non-default constructor. So therefore I do not need to create another class or maybe another extra step or headache. The same constructor can be used. The only difference is the content or the argument can be a different information, right? And I can over and over overload it, no limitation. Like for example, initially, let's say this is 1. In 1, I have no argument, no parameters inside the argument. And then let's call this one 2. In 2, I have 1 double. Again, I overload. Let's call this one 3. And in 3, I have 2 double. Now, somebody may ask me, can I use a different data type? Or can I mix and match? Yes. The answer to that question is yes. You can have, for example, in here nothing, and then next time, let me use a different color for you. In here, you can have nothing. But in here, you can have double. Next time, you can have double and integer, even mix and match. Or you can have maybe just a string, even completely different. Not even double, not even integer. You can have char, you can have a string. Make sense? Right in here, I have one example for that. Inside my constructors, look at here, you can see the same. I have the same constructor, box, one time with 1 size, and next time I'm having 2 double. Next time I'm having 3 double. Make sense? Because I'm creating different boxes, a cube, a skew, a square base, and then a random box. That's why you can overload it over and over. Any questions so far? Everyone clear? Next, the only remaining part in here, of course, another thing I'm going to practice with you is how do I use array while I'm having a constructor? A structure of using an array with constructor is very similar to what we know about general use of array, but I'm going to quickly review with you. In this object, let's say my constructor is, this is the name of my constructor, is called inventory item. As soon as I say name of my constructor, now I'm expecting you to understand name of constructor is the same name of class, right? This could be the same name for the class. Inventory item, and then I'm having inventory to be my array. When I say array 40, what does it mean? Who can tell me? What is 40 in here? Yes, go on. 40 is, yes, 40 is the size of the array, not number 40. Not the array inventory being set to number 40. It's not number 40, it's the size. Means I can have 40 items inside this inventory. Suppose if this is grocery store, inventory is your grocery store, you can have 40 maybe apples inside that inventory. Or if it is anything else, maybe classroom, then you can have 40 computers inside that classroom or so on. Make sense? So now, if I'm having another example in here, and size of the array is smaller size, makes it easier. For example, I'm giving it like size 3, and I'm gonna put hammer, wrench, and plier in it, a little bit more related to engineering. So now I'm having an array with size 3, and I'm having 3 items in it. What if the constructor need more than one argument? This is a constructor, right? I just said this is a constructor. What if I need more than one argument? How do I initialize? I initialize it like this. Very similar to the formal function. The way that we initialize the function, we have to do it exactly the same or very similar. Look at here. This is the constructor. Inventory is the array. Inventory size 3. And I initialize, I open and close my curly bracket. And since I had hammer, wrench, and plier, in order to initialize, I must use the name of the constructor. For me, it is inventory item. I do not need to use the inventory because inventory is the name of array. It's not the name of constructor. I'm not focusing on the name of the array. I'm focusing on the constructor. Therefore, I'm going to say inside this constructor, I have hammer. Suppose that I'm looking at the size and the, sorry, not the size, the quantity and the cost. Quantity and cost for the hammer. So I'm going to say I'm having 12 hammer. Each cost $6.95. And then for the other one wrench and for the other one plier, if I'm initializing, I have to include all the information for all 3 of them. This is one method. You cannot leave, for example, in here 1 comma, in here 1 comma, and then instead of giving it a price or whatever, leave it blank. If it is blank, it will give you error. Either you have to include nothing and just say hammer, wrench, like very, very similar to this one. Just say, this is what I have inside this inventory. But if you want to give it more detail, it has to be the same for all of them. You cannot have comma with blank spot in there. Make sense what I mean? Another example, it's not necessary to call the same for all of them. Still, you can say, just hammer, no more information about the cost and the quantity, just hammer as I have it right in here. But you may now, in case you want to give detail to wrench only, you must again use the constructor name. I'm going to maximize. Anytime you want to give it detail, you must use the constructor name and give detail to only wrench, and again, no detail for the plier. So you got the point. Anytime you give detail to it, it must come with constructor name and include all the information for that certain inventory inside parentheses, right? But you must make sure that there is no blank spot. If you have comma, then between them, it must be some information, some value, some numbers. Or if it is characters, some characters. Yeah. More than one?
Like the inventor item can do the same thing for the hammer and the plier. It's all the same.
We did that in here. Look at here. We did the same for all 3. This is what you mean? Yeah. Either you can have detailed information for all of them, very similar to each other, or you can have only for one of them or 2 of them, not for the other one. But anytime you want detail, that's the point. Anytime you want to detail them, you have to use the inventory item or the constructor name again. That's the point in here. Make sense? So now let's look at UML, and then we will move to the Visual Studio, and we will leave this lecture slide. So kids, every single one of you are engineering students sitting in these seats. Therefore, I'm confident to talk about more of engineering example in here. Suppose you are electrical engineer student, or anyway, you have some electrical courses. The very first thing that you will be trained with is being able to read a schematic, electrical schematic. Is there any other name for it? Yes, some people, they call it blueprint, right? Any blueprint means any map to follow and finish any task. Even for electrical engineering, instead of a schematic, you can say a blueprint, right? So this is computer, software engineering, or programming, anyway, engineering. You may need such a blueprint. You may need such a plan, such a platform that you can step by step follow and finish the task, or let's say create that certain object. In programming, we do not have it exactly like electrical engineering, a huge maybe a schematic showing how you connect your resistors to your capacitors, capacitor to diode, maybe diode to another object. If you have some load or actuator, how your actuators, motors, or whatever actuator that you have are placed inside the circuit, because you cannot just grab a bunch of components, just put them on the table, and out of blue start connecting them together. If you are not expert, if you are expert, yes. If you are not expert, you cannot just go grab lots of components and randomly connect them together and expect some output, right? That doesn't work most of the time, right? So same thing in here. And if you do not have a schematic, and next person, suppose you are working in a company, next person supposed to troubleshoot your circuit, they are gonna have a really tough time to figure out what you did, how you finished the wiring and everything. Now, what is wrong, to go back to their fix it. And if they want to fix it, what's the right structure of fixing it? Therefore, that's blueprint in electrical engineering. That electrical schematic acts like a guide, step-by-step guide. Here in programming, we have another similar things, but just for programming. And that's what we call it UML diagram, standing for Unified Modeling Language. Initially, before starting putting everything to some syntaxes, some keywords, which might not really make sense to everybody right in here in Visual Studio, we can write down everything in human language, which is more understandable to everyone. And then we can step by step convert it to machine language. In here, C++. So far, so good. So now how do we do that? I'm going to go back to the beginning of this one. Suppose I'm having a class. So UML diagram for a class has three main sections. The very first section, or this first cell in here, is where I'm going to include name of my class. In this example, if my class name is box, then I have to put down box right in here. Make sense? And then, and of course, the UML diagram comes first. First, I have to have the UML diagram, then convert it to this programming in here. Way around. First, create this one, and based on this UML diagram, you can convert it to C++ programming. So now, another major section for the class, while I'm looking at UML diagram, is having a spot which is right in here to include my private member. So far, so good. And the last one is gonna be your public members. So you have only three main sections for the class while creating a UML diagram. Let's put one other example in here. Before that, look at this example. I'm gonna maximize it for you. This is the same rectangle example that I had it in previous slides. So remember I said first spot is the name of the class. Therefore, the first section is supposed to be rectangle. So far, so good? The students in the back of the class still with me? So second part is your private members. In case you are not the one who created this one and somebody else created this one, you have to only follow it and convert it to C++. If you pay attention, you can see here these are not something random. They have meaning in here. If you look at here, this is shown with minus. This is shown with minus. Therefore, you need to know that anytime you have minus before the sentences right in here or words, whatever it's mentioned, then you can say this is a private class member. So far, so good. And then if you do have positive or plus right before each of this, you can say this is public. Every single public member, class member is going to be shown with a plus. Every single private class member is shown with minus. So far, so good. If you want the written version of what I said, just for your reference, you can go to the previous, look at here, I have it in here, minus, and the next one is going to be plus. This is just a written version of what I explained. Now, one example in here is rectangle. I'm having the box example on the other side. Somebody tell me, consider this box example and tell me if I have to replace this table instead of rectangle to box. Box is going to which one? Yeah. Suppose this is 1, this is 2, this is 3. So what should I put down in 1? Box. What should I put down in 2? Based on what I have in this class. This is my class. I'm gonna convert UML diagram for the rectangle to the one for the box. So what should I put down in 2? Say it.
Minus length colon double, width colon double, and height colon double.
100% correct. Since for private member for box are 3, not 2, then in here I can have still width and length are double. In here also are double. I can add another one, height colon double. How about 3? What can I put down if I'm gonna just change this one to box class? Then what should I put down in here for the box in number 3? Someone say, yep. All the public members of box, anything in here. I have a lot of public members, so I just highlighted one of them, but suppose only the constructor. All of them goes here. Now you have that understanding. Let me quickly show you another example to become 3 example and make sure everyone got the points. And then we are going to finish the slides right in here. So one more time. This one was box example. I had rectangle example in here. And now I'm going to look at the inventory item example. Again, number 1 is the class name, which is inventory item. Number 2 is the private members for the class inventory items such as description, cost, and units. And number 3 is going to be all the public. Somebody tell me, what is this? Just a review. Yeah. Default constructor. Do I have a destructor in here? If so, which one is destructor? Yeah. This is child. Yeah, this one is your destructor. Which one is my mutator? Do I have mutator in here? Which one is mutator? Yes. All these sets, all these 3 sets are mutator or setter. Do I have accessor in here? Yes, go. Do I have accessor? All of this getter, these are my accessor. So somehow we reviewed everything about the class. So I'm gonna just pause in here. I'm gonna give you a few minutes of break, and then we are gonna start programming inside the Visual Studio. So let's just first review what we have. If I go back to the header file one more time for everybody, anything that we have under the header file, what do we call it? If I'm gonna just leave you some message in here, what is the name of this file? Header file, or the platform, or the file that I'm having the class being defined is what we call it a spec file or a specification file. This is your specification file. Under the specification file, either you can use pragma, remember, or you can use hash if and if the name of the object, and the mandatory part is finishing it with hash and if. So far, so good. So now, remember I was planning to create a box since we already had it, this part. I trust you guys have this information from the previous example. So, but still I review. In this example, I have a box, which is a class. My private members are already defined. My public members are already defined. And I'm going to keep adding more information in here, right? So for example, at this point, I'm going to teach you how to overload. So I leave one example in here. I'm going to add more. I already have mutator or setter. I already have accessor or getter from the previous example. But today I'm going to overload my length to one more time show you how to overload your function. Of course, anything in here that you can see, for example, I created one box, which is a just default constructor, and then another one as a cube, another one as a square, another one just a box with different sizes. These are also overloading, but this overloading is overloading your constructor. In this part, you can see I overloaded the constructor. I explained it before. Now I'm going to show you how to overload your function. That's one thing. And right after that, I'm going to teach you, these are the overloading of your constructor. I'm going to teach you how to create an array of box, how to create 5 random boxes, how to create a box with a pointer variable, and how to create overload, that overloading function, how to add a smart pointer. One more time for your reference. Underneath this main function, you can see that I have another function called display. And this display function, in case you want to see what is this, I'm going to maximize for anyone even out there they want to watch this video. This display function is only helping me to just see out all of the information that I'm looking for. For example, height, length, width, volume, and surface area. Now, this volume, surface area, and all of my functions, such as functions plus getters and setters, where do I have to define them, kids? Under .cpp, right in here. Box.cpp. What do I call this one? Implementation file. So pay attention. Box.cpp is going to be my implementation file, and everything such as my functions are just explained right in here, such as how do I create a cube, how do I create a square base, how do I calculate volume and surface area. All of them are defined under box.cpp. So far, so good. So I don't repeat this because these are coming from the previous example. Just keep them under the .cpp. Keep your class specification under .h. And now stay with me to go to the main.cpp and start creating more details. So First one, I'm going to create array of box. How do I create array of box? Remember, anytime I'm going to maximize to make sure everyone can see. Still, if you have question, stop me, ask me. If you get error on your compiler, just let me know. I'll help you. So I'm going to just go ahead, put a slash asterisk right in here. And I'm going, because each time I'm going to debug for you. Therefore, I'm going to, for now, comment all this part to avoid error. And one by one, I'll activate them. This way, I can, each time after each example, give you a debug. How do I define a box, array of box? So I'm going to type box. Box is the name of the class, remember? And since I want this to be just nicely organized inside the console, you may see I already left for myself some of these things. For example, for the first part, example one, it was just creating different boxes. So I see out, this is my example one. And after I hit the debugger and I look at my console, everything is very organized and I can tell this answer is from which part. You may want to do exactly as I did in order to organize your output. So I'm going to say box, and then what would be the name? I can give any name to my, so I'm going to say boxes, and I need 5. I'm looking for array of box. Therefore, I'm going to say box, and I'm going to give it 5. 5 is going to be the size of my array. This is how, like exactly how we define any regular array, but the only difference is I have to use my class name in here, not double, not integer, not char, not, since I am practicing class. So right after that, this array of box is going to be random, so I can use a strand. Use a strand, and then give it time, parentheses inside 0, and then finish it up with semicolon. Follow me to not to stay behind and be able to debug each of these examples. If you have error in one of them, probably you are gonna have like difficulties debugging the next one. So pay attention. I try to keep it as maximized as possible to make sure everyone can see. So right after that, since these are going to be array, I'm going to put them inside the loop. So I would say a for loop. I'm going to define my looping variable as an integer. I give it the variable I. You can start with any other variable name and start looping it. How many boxes do I have in here? 5. So what would I say right in here? You tell me. It should be I up to less than 5, because my max is 5, and then semicolon I plus plus. So far so good. And since I'm having some detail in here, I'm gonna start my open your curly bracket and then give it more detail. How do you do this random boxes? Say well, okay, it's back. For a second it was frozen. Say boxes. And right after that, remember this one was an array. Now, what do I put inside this array? I have to put I, because now I do have a looping variable. Then assign it to box. And then remember, this is your random box. Then say rand. And then, of course, you need to include your parentheses. And then close your rand. And then percentage of 9 plus 1.0 comma, again rand, again parentheses, and then right after that again percentage 9 plus, what do I put in here? Again 1.0, again rand. I have 5 of them, right? And so what else? And then parentheses, right after parentheses, what else again? So I have rand percentage 9 plus 1. Rand percentage, so in here, I have some typo. Rand, this is not 5. This is percentage. I hold the shift, but for some reason, instead of shift, it is type 5. Okay, so percentage 9. And then percentage 9. So box is the same box. Box rand percentage 9 plus 1. Rand percentage 9 plus 1. And the third one, rand percentage, hold shift tightly sometime, percentage 9, and then plus 1.0, and then close it. And then, of course, you have to include semicolon. Now, remember I said I already defined this display. So now I'm going to use the display. And what do I want? The boxes, the 5 boxes I have. So I have to just use the exact same name, boxes. And then remember, boxes is array. But what do I put in here? I. And then close it with semicolon. Look at here one more time, the whole thing. Percentage 9 plus 1, percentage 9 plus 1. And then you are good. Check your errors, if any, fix them. If you have no error, I don't have any error. Now I created array of 5 boxes. This is array of 5 boxes. Now if I give it a try, let me see if I can see the results on console. Debug it. So far you should have example 1 and example 2. It takes some time. It's coming. Here we go. A little slow, but it's here. So look at here. This is my example 1. I'm going to maximize for everybody to see. This is example 1. All of those square base, cube, and everything. Example 2, remember I wanted array of 5 boxes. How many boxes I have? 1, 2, 3, 4, 5. So far, so good. Everyone able to create the array of 5 boxes? Yes or no? Students in the back of the class, still with me? I'm coming to check yours. Practice, kids, practice. No practice, no learning. So now, we already practiced that one. Now I'm going to activate the next example in here to teach you how to create 5 random boxes. I already created 5, array of 5, but how to create random box. 5 random boxes means what? I'm going to just go ahead. Actually, this one I created with random. I'm not, since I created with random example 2, example 3, again, I'm going to create just array, but this time I don't create random. I already created 5 random. So I'm going to create just 3 boxes. Let me go back and see if example 3, I already created like 5 random boxes for you. I'm going to create this one, a box with a pointer. A box with a pointer, because I already created this one. This one is extra. I'm creating a box with a pointer, which is this one. You already got that one. So then I'm having this one to be deactivated. So let's go for a box with a pointer variable. How do I do that? Example 4. Example 4 is asking, go create some pointer. Remember I said in order to create some pointer, I'm going to again use box. Do the same. I'll come back later and I do something else in here. Anyway, more practice is better. But for now, let's focus on pointer. Pointer means you use asterisks, right? Therefore, give it a name. It could be any name. I'm going to say, since the object is box, I'm going to say PTR box. You can use any other name if you would like to. And I'm going to give it null PTR. Everyone knows what null PTR is? Tell me. Gabriel, what it is?
It's a null pointer.
Uh-huh.
The zero.
Sets the address to 0. Then again, call your PTR or your pointer, which is for me PTR box. And remember, I said we are going to allocate memory. Using these two examples one more time, we can review what's the difference between using regular pointer and look at here in the next one. I'm going to also give you a smart pointer. So let's practice it first with regular pointer. So I'm going to say PTR box, and then I have to say new in order to allocate memory, and the name, it was box. Therefore, I would say new box, not new box. New is the allocate memory. That's not the name. And you can give it the size. I'm going to say it's much easier for the sake of time, instead of C in, C out, just give it some size right in here. Or, of course, you can have C in as well. That's another method. And then again, I have to use display. I already have the display function, and I'm going to display the results of this pointer. So I would say asterisk PTR box. I want it to be displayed. Just display those ones. So one more time, make sure you have no error. One more time, because this display is this function. Anything I create, I want it to be displayed. So now I'm going to have example 3. Example 3, let me put down in there also for you. For example, I'm going to create another array of 3 boxes. I already created 5 just for extra practice. And then I will give a debug to both of them at the same time. So in here, I'm going to create again box. You may want to do it with me. I'm going to create a box with, I wanted to say boxes again. Boxes, but this one I'm going to say boxes 3 to avoid error. And then I'm going to say the size is 3. And then give it detail. Open your curly brackets. This one, you want it to become just boxes with size. Why I'm repeating this? Because in here I created a random box for you. Now what if I don't want a random box? Therefore, you have to give it detail. Let me maximize. If you don't want random box, then give it box. Each time you have to define the size. For example, for the first one, I'm going to say the size is 3.5, comma, and then again, what does it mean when I say first one? Then I have to say box. I want 3 boxes, right? That's why I say first box is 3.5. Then I'm going to say for the next one, 1. Somebody tell me what does it mean when I say 1 comma for maybe 0.5. Somebody tell me. Go.
Setting the dimensions for length is 1, setting the dimensions for width as 4.5, and height will automatically be 4.5.
Exactly. You got the point. But why I do not have 2 numbers for the first one? Do you know why? Do you know why I don't have 2 numbers for the first one? Somebody tell me, Jude. Why I have only 1 number for the first box? I'm looking at creating 3 boxes in here. Actually, this is going to be 3 boxes, and this is not random, but in here, I have created array of 5 random box, right? In here, I created 5 random box. Now I'm creating 3 boxes. So now, first one is just 1 number. Second one, 2. Third one, only 1. Why is that?
First and third one would be.
Exactly. This one is a cube. If I have only 1 number, means all length, width, and height can choose the same number. Make sense? And then if I have 2 numbers, means I'm creating a square base. 2 number is enough. And look at here, like very similar to this one. This is a square base. I give it 2 number and third one is gonna be just the same as the first one, and so on. Then what do I want to display in here? Then before displaying, since I am looking at like different boxes, so of course I need to display the information. But before the display, do I need to put inside a loop? Of course. So I have to say again a for loop. Again, I'm gonna say integer, and I start from I assigned to 0, and I continue I. This time, what would be the maximum? For the previous one, it was 5. How about here? Look at here. In here, I had 5. What should I put down in here? 3. Why 3? Because I'm creating 3 boxes. And then what is next? I plus plus. Do I need more? Do I need more information in here? No. So all I need is display this boxes. This box is 3. So this box is 3. I gave it a name, right, because I have another boxes in here to not to mess up with that one. And of course, you have to make sure this is going to be array. And then semicolon. Look at here how many example I added. Right now, I added array of 5 random box. I added just 3 boxes, and their information is seen right in here. And I added a box with a pointer variable. If you do not have any error, everything is like fine. As time, this is the previous one before I close the previous one and debug. So this is example 1, example 2. Now I'm going to close and I'm going to debug. This time I have to have how many example? 4 example. Let's see. 4 example. Now you know how to create random box and how to create a box with pointer, how to define array. So let's see. Maximize and look at all of your answers. So this is example 1, all those boxes. Example 2, it was just array of 5 boxes, remember? Example 3, only 3 boxes. Look at here. 3 boxes with those information we have asked for. And those, for example, first one was 3.5. Remember I said why I have only 3.5 one time? Because I want length, width, and height, all of them to be 3.5. Now makes sense? And for the second one, remember I had only 2 numbers, 1 and 4.4, 4.5. So the 1 is considered for both length and width, and height is the second number. Now makes sense what I did? And the very last one, remember I created pointer. And this is example 4, that was a pointer. And for the pointer, what was the number? I gave it 2.1. So far, so good, kids. Everyone got what I did. How do I do this? Okay. Now I'm gonna just close this one. Let's go back. Still, we can add more detail to practice more. So next one, I'm gonna create overloaded member function. So I'm gonna move still this one to activate. I'm gonna just leave this one as a comment for now to come back and add even more in there. So how do I create overloading? For overloading, before calling or before giving it detail right in here, I have to go back. Remember, overloading the actual function, because I'm working on a function, on an existing function. For overloading a function, I have to go back to my header file. And inside my header file, I have to just adjust it. Which one? For example, just overload your length. In order to overload length, I'm going to say void set length. Everything is stand as it is, set length as it is, right? But I'm going to just overload. It's double L, and this time I'm going to turn it to a string. I'm changing the data type. Simply means I'm overloading it. How do I do it? I simply say a string. A string, and still I'm going to give it of course, a variable. That's how I overload the function. I keep the data type as it is. I keep the name as it is. All I do inside the argument, which we call it parameters, I change the parameters to a new information, to new parameters. Make sense? And then I have to define it. So I'm going to say now, what is my length? I'm going to say length. This is length. This time I'm going to assign it to some of the functions that we learned before, so such as A to F. And then open your parentheses. We learn about, so my variable is S, so I would say S dot CString, S dot CString. And then, of course, remember you have to open parentheses, and that's it. Just get out of here, add a semicolon, and you are good to go. This is what we call it overloading. I'm going to move my message to here. This is what we call it overloading. I overloaded my function. Everyone got the point? Yes or no? So now, still I have one more step. Since I created this one, I have to go back to main. What do I do inside the main? This is gonna be my example 5. Inside the main, now I need to just call it, right? So I have to say, I created a box object before, so then I have to say, what is that new length? Because I'm overloading it, therefore I'm setting it to a new number. So I would say box, I had box object. This is what I created before. Dot, it was a set length. So set, it was length, right? And I'm just setting it to a new number. Maybe 3.5. It could be any number. And all I have right after that is just go ahead and display it. Display your box object. Box object. That's it. You got it? Everyone did this one? And in here, you have to have a semicolon. Okay, make sure all of the words are exactly the same to avoid error. If you have typo, for example, this one, make sure all of them are the same, otherwise you are gonna get error. So this is just overloading. I have one more left. And this one is gonna be a smart pointer, and then we are good to go for this one. A smart pointer, remember I said, why we use a smart pointer? If we use a smart pointer, we do not need to delete it anymore. Therefore, I'm gonna practice having a unique PTR. Just type unique PTR for a smart pointer, and then use the name of your class. For me is box. And then right after that, new, I created a new box, so box object, new box object. And then right after that, maybe give it a different name because I already have box object in there. I'm gonna make this one new box object. This is going to be a brand new object. I already have one object in there. This is going to be a different name, any name you can choose. And then use new because you are practicing allocated memory box, and then give it the sizes for the box. I'm gonna say 2.3 and then comma, give it another one, 5.6, and out of here, just give it semicolon and go and display. display function is there, so I just need to use it. That's it. And then display this smart pointer as pointer. I already called it new box object, so you can call the same thing and semicolon. There we go. So now check and make sure you have everything in here. Kids, remember one more time, since I used a smart pointer, you must make sure that you do have memory. If you do not have memory, it's going to give you some error. You must have memory in there if you are using a smart pointer the way I did right in here, right? So now you can debug. Maybe there is an error somewhere I have to fix. I'm going to go back, check all of them. Okay, so now I'm done with all of the example. Before I give it the very last debug one more time. First example, it was just cube, square base, and just a box with different sizes. Then I created 3 boxes, right? Just boxes with different sizes as an array. And then I created 5 random boxes. Then in here, I created regular pointer. And finally, for regular pointer, remember you need to delete, right? If you don't delete, you have to delete your pointer, right? So if you don't delete, it's gonna just mess up. That's one thing. Add the delete in here. And then I created just overloading. And finally, for the unique PTR, you do not need to delete anymore. So now if you give it a try, you can have like 6 examples being solved. Here we go. I'm gonna maximize for everyone to see. This is example 6. I already showed the rest, so I'm gonna just, first example, 4 boxes. Then I have like 3 boxes as an array. Then I have 5 random boxes in example 3. Example 4, I have just a regular pointer. Example 5, I have overloading. And example 6, I have smart pointer. Now, any question? And if you do not have any question, we are good. I'm gonna stop this one and we'll see you next time.